Welcome back. In the last video, we looked at section 2.1. We started with indeterminate forms. We looked at three examples. In all three cases, we had a form and we had two limits that corresponded to that form. So for example, here we had two limits that gave you 0 over 0, and I showed you that in these cases, you don't actually get the same value. Right, so let's put this together. In the worksheet, we'll do similar exercises, we'll do similar examples, but for limits of type infinity minus infinity, 1 to the infinity, and infinity to the 0. So again, if you get something like one of these three forms by evaluating your functions, you will not be able to conclude. You'll have to do some simplification. All right, so let's put that in the takeaway. When trying to evaluate a limit, that looks like this. If you get either 0 over 0 or infinity over infinity, then evaluating the function separately gives you no information about the actual limit. Same thing, when trying to evaluate a limit that looks like a difference, if you get either plus infinity minus plus infinity, or minus infinity minus minus infinity, then evaluating the function separately gives you no information about the actual limit. To figure out the actual limit, you'll need to figure out which one of f and g is actually going to infinity faster. When trying to evaluate a limit, that's a product, if you get 0 times infinity, or infinity times 0, or minus infinity, something like that, then evaluating the function separately gives you no information about the actual limit. When trying to evaluate a limit, which is a power like this, if you get either, we saw a bunch, we saw 0 to the 0, and then on the worksheet, you'll see 1 to the infinity, and you'll see infinity to the 0. If you get any of these three, then evaluating the function separately gives you no information about the actual limit. And so because of that, we'll call these indeterminate forms. So we have 0 over 0, we have infinity over infinity, we have infinity minus infinity, we have 0 times infinity, we have 0 to the 0, we'll have 1 to the infinity, and we'll have infinity to the 0. All right, all of these are indeterminate forms. That means you need to work harder to get the limit. You cannot tell from this. All right, so our goal in this chapter is to use derivatives to evaluate these types of limits. Our main tool will be L'Hopital's rule, which we will state in the next section. Just a note, in this chapter, it's useful to have a symbol for just infinity, not plus, not minus infinity. So it will be useful to write infinity to mean either plus infinity or minus infinity. To avoid confusion, I will be careful to always add a plus when I mean positive infinity. All right, so when I write something like this, it means plus or minus infinity over plus or minus infinity.